Hello, this is Michael Watry, and this is review for the makeup test. Okay, so let's talk about some of the problems that we had on the test. These are modified versions of these problems. So here we have 12 times 1/4 subtracted by 3a. So we can distribute the 12 into parentheses to get negative 12/4 minus, no, plus, because a minus and a minus multiplied together will create a plus. 12 times 3 is 36. 36, and then we have a. Now negative 12/4, 12 divided by 4, that is 3, negative 3 plus 36a. This one is the same story. We distribute the 11 and the 11. 11 times 3 is 33a, minus 11 times 11 is 121. Now that should be pretty easy. Then when you add multiple, there are a few extra steps, but it's pretty much the same. Take 2 times the 4. You take the 2 times the 11. And you take the 2 times the negative 6. For you have 8 x's plus 22 y's minus 12 x's. Now you can simplify this further by combining the 8x and the 12x together and using this. We can find out we have a positive and a negative, so our way will be subtracting. So we have 4. The bigger number is the 12, so it will be negative. Negative 4x plus 22y. This one over here is more of combining like terms. So we have a plus 1/2 a minus a over 4. So all of these are compatible with each other. This is 1 times a plus 1/2 of a minus 1/4 times a, if you'd like to look at it that way. So adding these together, we find we can't add 1/2 and negative 1/4 without first finding a common denominator. Common denominator here would be 4. So 2 times 2 would be 4. You do the same to the bottom, same to the top. 2/4 a minus 1/4 a. We have 1a plus that. So 2/4 a minus 1/4 a is 1/4 of a, plus 1a, we would get 1 and 1/4 a. This one, we have almost the same thing as back here. We take the 3a, distribute it inside. Now, for this one, we take the 3 times the 4, the numbers in front of the a, multiply them together. It's a negative 4. To get negative 12, and we take the a and multiply it together to get a squared. Then 3a times negative 5 would be negative 15a. Bring this down, plus 6. Now, you cannot add these together because these have different variables at the end. This one just has a singular a, but this one is a times a. So this right here would be the simplest version. So now going on to the square root section of the test, we had a problem similar to -9 times -49. We took the square root of that. Now, for this, we know if there's a negative inside the square root, we can take that negative out. We get an I times the square root of 9, which we know is 3. So I times 3 and times. There's another negative sign. We can take that out as an I. Then there's 49, which is also another perfect square, which is 7. So we have I times 3 times I times 7. If we multiply the i's together, we get I squared. If we multiply the whole numbers together, we would get 21. And so we know what I squared is. We talked about this in class. I squared is equal to -1. So we can take 21 times -1, and our answer would be -21. Okay. Another question with square roots. We have negative on the outside of the square root symbol, -36, negative root 36 plus the square root of -9. Now, since this is on the outside of the square root symbol, also called a radical, then it doesn't affect what's in there, so that can just stay out there. We know that the square root of 36 is 6, so that would be -6. Add on. Now this time, the negative sign is inside it, so we can take it out with an I, and the square root of 9 is 3. So we have -6 plus 3i, and we cannot simplify this any farther because 6 has 0 i's and 3 has an I. So that would be 3i minus 6. Okay. So on to a problem with fractions. We have -3/11 times 2 -9. Now, a fun thing you can do with fractions is if you are multiplying and you find them across from each other, you can say that these two are both divisible by 3. -3, in fact. So you can take those out. Divided by -3, this one would be 1. This one would be 3. So you can go on, take that out. 1 times 2 is 2. 11 times 3 is 33. So we would get 2 33rds. Another fractions problem, this time if you are dividing it, we have 8/3 divided by 2 39ths. So we can take this one. Whenever we are dividing fractions, we can multiply by the reciprocal, which just means we can take 8/3, our original number, and multiply it by the flip side of this one, 39/2. Taking this, we can use the same trick we did before. 8 and 2, they are both divisible by 2. We have 1 and 4, and 3 and 39 are both divisible by 3. we get 1 and 13. So multiplying this together, we have 4 times 13, which is 52 over 1 times 1 is 1. 52 over 1 is same as 52. And that would be our answer. One more kind of relating to fractions, we have 3 times 31 minus 11 divided by 6 plus 3 times 2. Now, you could go about this two ways on the top. You could either use the distributive property to distribute this into the parentheses, or you could use the simpler route, and since they are already in the parentheses, you could just perform this operation inside, which is what I am going to do. So I would get 3 times 31 minus 11 is 20, divided by, on the bottom, you have 6 plus 3 times 2. And our order of operations, multiplication comes before adding, so we would have 6 plus 6. So now we have 3 times 20 would be 60 divided by 12. 6 plus 6. And 60 divided by 12 is 5. One of the first lessons in Mr. Grove's class was the square root of a number that was not a perfect square. And I think it's a pretty neat trick that goes in there. So we have the square root of 26. So what you can do is you can take it, you can find the lower square root, in that case is 25, which is just 5 times 5. Then the square root higher than that, which would be 36, which is 6 times 6. So you take the 5, and that gets put into your final answer. Now with this, you would take the regular square root that you started out with, divided by the higher, subtracted by the lower over the lower. In this case, we would get 1 over 11. So then we would take this number, bring it down here, 5 and 1 over 11. Now, the next part of the test was naming which sets of numbers different things belong to. 11. Is it a rational number? That is where we would start off. Yes, it is rational. It can be represented as 11 over 1, which is a fraction. Although, then we go into more steps. Is it a singular number with no decimals or fractions? Well, yes it is. So, it is also an integer. So it is rational. And it is an integer. We can go farther. Is it a whole number? So whole numbers are just numbers that aren't negative. that follow all the criteria of these previous ones. Yes, it is not a negative number. Now there's one more step, which is natural. Natural numbers are whole numbers, but they don't include 0. Is 11 0? No, it is not. So it is a rational whole natural integer. This one, 1/6. Is it rational? Yes. It is represented as a fraction. But it is not an integer because it is not a whole number. It is not a number without a decimal or a fraction. And we have this one, the negative square root of 16. Now this one, if we simplify it, we can say it is negative 4, because square root of 16 is 4. With the negative on the outside, it is negative 4. Is it a number that can be represented as a fraction? Yes, it can be represented as negative 4 over 1. And it is not a decimal or a fraction in its most simplified state. So yes, it is an integer, but it is not a whole number because it is negative. So that would be a rational integer. Now this number, which is 5i. Now in this case, I stands for an imaginary number. So if you have, even though 5 is a rational whole natural integer, since it is being multiplied by an imaginary number, it is not rational. So this is an imaginary number. At the end of this test, there was a bonus question. So this is how I would walk through one of the bonus questions. So we have the square root, negative 81 plus 5 times the square root of 16 minus 30 minus negative 31 plus 41 minus the square root of 64. Then you take all of that and divide it by the cube root of 27 plus negative 2. Now this is a very big problem. So let's try and break it down into smaller bits. So we know square root of 81. Let's try that. So the square root of negative 81, it has a minus sign. So we can take the I out of it. And 81 is a perfect square. It is 9 times 9. So on the outside we have 9i. Plus, over here we can simplify the square root of 16. It is 4. So 5 times 4. Minus, we take negative 30 minus negative 31. If you minus a minus, it becomes a plus. Negative 30 plus 31. That would be negative 1. So now we have 5 times 4 minus 1. On this end, we have plus 41 minus, and then the square root of 64 is 8. All of that divided by now we have something we probably haven't seen before. It is a cube root. It just means, say you have 2 squared is 4, And so then you take the square root of that number, which is 4, and you would get 2. It's the same way as if it was, if you have 2 cubed, you would get 2 times 2 is 4 times 2 is 8. Then, so the cube root of 8 would be 2. So you need to find out what is the same number that can be multiplied by itself. 3 times equals 27. So, if you look at it, 27 can be represented as 9 times 3. 9 is 3 times 3. So, 3 times 3 times 3 is 27. Then we have 3 plus negative 2. So, now we can take on this equation more. We have 5 times 4, well, 9i plus 5 times 4 is 20 over, we can work through this quick, negative 1 plus negative 8 is negative 9, and plus 41 would be, so we have 41 minus 9, that would be 32. So 20 plus 32 over 3 plus negative 2 is the same as 3 minus 2, and that is 1. So you have 9i plus 20 plus 32 divided by 1. 20 plus 32 is 52 over 1. That's the same thing as 52. So our answer would be 9i plus 52. I hope that explains some things for you. If it didn't, comments should be enabled for this video. So just leave a comment on this video if you're confused about anything.